Hey everyone, this is Hodge Gamble, and this is my final submission for Digital Forensics 6963, summer 2015. And this is a program I created called SQLGrab. It extends an existing program called Autopsy, which for those of you who are familiar with the digital forensics world, you know what Autopsy is. And Autopsy is a pretty nice program, right? It'll take disk images or your logical files and carve them up. Find them, find data within them, find string, keyword searches, phone numbers, anything. So if you got a hold of someone's hard drive in an investigation, you can very quickly use this program to find all sorts of things. And one of the things I noticed was it had the ability to find SQLite files. SQLite is a database that is used by Skype to house chat messages and the like. It's used by Chrome and Firefox, I believe, to store browsing history. And this program did pull in some of that, but that was about it, right? So you would find these SQLite files and you get metadata on them, and you'd see the strings field, which is useful, has all the data in the database dumped out in this nice string format, but there's a lot there, and so it's really hard to parse. And so what I did was I augmented the program, and I said, well, first things, let's go ahead and create this nice table view. So each table in the database gets its own tab with data in it. Right? And it's broken out in these nice views, so that's a little bit easier to look at, right? And the other thing I wanted to do, and this comes into more of the forensics role, is I wanted to create a way we could view records that had been deleted, or even tables that had been deleted, right? And this is an example. So earlier today, I deleted all the customers in this database and said goodbye. You might imagine that would be useful if you were trying to avoid letting someone know who your business contacts were. Unfortunately, SQLite doesn't just get rid of them, right? Like we find they sit on the hard drive until they're written back over. And in fact, that's what we see here. My program goes to each database page, which we'll get into in just a second. It finds unallocated regions of space and pulls data out of it. So here we got Dan Peters from Brussels with his phone number and his email. And we got quite a few of those, right? So there's the whole customer's SQL table that was deleted. Arguably, obviously there's some characters in here that aren't ASCII, but we got the bulk of them, right? So whoever thought they deleted their customers didn't. All right. So there's another section of deleted data too. Earlier today, I went in and deleted the #1 artist in here, which was AC/DC, sorted alphabetically, and they're gone from this table. But if you go look down here on this last page, you'll see there's a free section. So before we had page with unallocated and junk, here we have a free section with a free block and AC/DC located there, right? So even if you delete like a portion of a table, a record, it'll wind up in these free blocks, and then we can still get it. So, and I'm going to go into what the free and unallocated is in just a second. Excuse me one moment. Alright, so I'm back. Okay, so SQLite stores everything in one file. And this is a blog that was very useful in understanding by Mr. Monkey here, Cheeky 4 and 6 Monkey. So he has a nice write-up, and he borrowed information from another forensics analyst, Maria. And Maria actually provided the algorithm to parse all of this for both of us. And so all credit to her for doing that in Python. I definitely took it and have used it in my code and cited her work there. So thank you to her. All right, so within SQLite, there are a series of pages, right? We've already seen that. Over here on our program, there are pages, and I flagged them just with this little page here. Okay. Within these pages, the first thing is there's a header, and like any header, it's going to tell you what it is. It's got this 1 byte here, and this 1 byte has a flag, and converts to a decimal number, and that decimal number tells you what that page is So what data is housed in that page? And so for most of SQLite, it's structural, but but there are obviously data pages, and these data pages that store user data are leaf table B trees, and they're flagged with decimal 13. So we look through our database and we look for these pages that have a flag of 13. And once we found one of those, we know we've got user data. So what we do from there, and there's a couple things. First, we can look at the free block. So this is a 2-byte short that points to an offset that is a free block within the cell area. So this purple here is all user data, so data stored by the user in the database. And so when you delete like ACDC, it creates a free block, and this points to that free block. And they create a chain because a free block points to the next one, and so on. So the free block has a couple things. It's got a 2-byte pointer that points to the next free block, or 0 if there are no more, and a size. And so what we can do is we can jump to these free blocks, read the size, and grab the rest of it. And that's how we were able to find ACDC. And that was the only deleted block that was still in a free block anywhere in the database. So that guy had 0 and didn't jump on. Now earlier we saw the whole customer table was unallocated, right? It was an unallocated space. Well, that you would imagine would happen when you delete a lot of data, especially if you deleted a lot of data and then the database got refragmented. So how do we get to our unallocated section that we see here? Well, there's a couple things that help us in the header. The next thing we see is the number of cells used in this page. So that tells us, okay, how many cells do we have in this purple section, right? And it's 2 bytes. It tells you how many cells. The next thing you have is this first used cell offset. So after the header and the cell offset array, you have unallocated section. This points to where your data actually starts. So it's important to understand that SQLite actually grows from the bottom of the file towards the header. So this tells you where the data actually starts. So we've got that, right? So we know the beginning, or I guess you could say the end of the unallocated section. The next thing we know the header size. We know how big that is already, and you can read it on the SQLite page. It's a standard size, so you know that. And then we have the cell offset array, and all the cell offset array is 2-byte sections that point to all the cells in this array. So we know the number of cells in this array, right? And we know that these are 2 bytes, so 2 times number of cells gives you the cell offset array length. So there you go. So now you've got the beginning or end, however you want to view it, of the unallocated area as it bumps against the cell offset array, and then the beginning or end of the unallocated as it bumps against the cell array. So from there you just read this area, right? Here you've got all this unallocated space. Now a lot of this, as we saw, can be garbage, but there can be useful things in there, especially if someone hastily deletes a whole table thinking it's gone, and we can still grab it. So that's kind of neat, right? So I wanted to show another example of it. So earlier today I created this little sample database. Here we go. And this sample database is pretty tiny. It's just got one table, which is field, and it's got 3 values in it, right? So let's look at those. Actually, it appears it updated and pulled in my deleted value. So originally there were 3 values in here, 1, 2, and 3, right? So if we looked at the text, we see that there's 1 and 2 and 3 in here. But if we go here, they're gone. So number 2 got deleted. And if we go to deleted text, there he is, right in that free block area. So we found a page. There's no unallocated area, but there is a free area. And so we started jumping out in that free block chain, and then we found sample 2. Unallocated is there, it's just down here. So originally the database, if you can imagine, had 1, 2, and 3 in it. So it looked like this with a 2 there, but it's been deleted. But we still got it, right? We still found it. And this was going to be the example of the deleted data, but it's just the same thing now. And I mentioned earlier that Skype uses SQLite. And so I want to show you. This is the Skype database. There's the raw text, and if we go to the SQLite section here, it takes just a second. Skype's database is very big. You can see the whole database. Now there's some personal data in here, so I don't want to get too far into it. But you can see the contacts. There's calls. Right? There's an alert table, contact groups, messages. I don't want to click on them because I actually have some of my personal messages in there, and chats, right? And then you have different conversations which are in here. I actually deleted those earlier today. But you got participants, right, and accounts. And so this is really useful because it'll show you all these if you were to happen across a Skype database. And there's more of it in the deleted text, right? Like if we went in here, you could see the conversations I deleted. And so you kind of scroll up because it loaded. And there's a bunch of unallocated data in here, but you can see there's the deleted conversations. This is like a spam conversation, right? So I do it from somebody the other day. And there's a couple other ones. There's Eric and Steven, some friends of mine talking. So that's kind of nice. But one of the things that I wanted to do, and this was my third and last feature, was make it where you could run queries on these. And I know there's other SQLite applications out there that can do this, but I really wanted to make Autopsy a little bit better than it already is because it's such a great program. So I added a report. Now this report, just come here, and you have to enter a few pieces of data right now. I'd like to make this a lot better, but as of right now, it still needs some augmentation. So what you do is you go to your data sources. You have all these data sources. You go and you look at your object ID. So that's the data source ID or content ID. And then from here, this Chinook database, you want to know the name of the file, and there it is, right? Chinook SQLite.SQL. So let's go ahead and run our report. So we go here, SQLite report. We know this guy was 1, right? And then we say Chinook underscore. And then that's kind of silly, but we say select star from, let's say artist, right? And then we say finish. And you can get crazy with a SQL in here. You can, if I wanted to, I could pull all the conversations out of my, all the messages out of my Skype database and put them in a chronological order by timestamp. But I'm not going to do it. I did it earlier, and I noticed there was some personal information in there, and so and we're just going to use the Chinook database. So let's say finish. Okay. And went ahead and ran. This is going to create a nice CSV for us. So we click it, click on our CSV, boom, there we go. So it went ahead and ran that query, and that's just a basic data table query, right? But you can see it pulled it all in and put them in there for us, and obviously there must have been a comma in some of these names because it got split out. Like I said, it's pretty raw, but it's nice, right? And so if we were to, no, we don't want to save it. If we were to go, we could get pretty fancy with this database. We could go to the SQLite table and say, hey, show me before I deleted all the customers and what they purchased on certain days and whatnot. So, okay. Let's go into the code. I've already mentioned some of how it works. So what we do in Autopsy, there are modules. There's report modules and ingest modules. And so what I've done, content viewer modules. I've created 2 of those. I've created a content viewer module, which we saw already was the SQLite. This is a content viewer. And then the report module, right? So there's two extensions. So this is our grab panel. So this is the driving class for our content viewer model. So whenever you click on that SQLite tab from earlier, this guy, it calls the set node method. And what we do from there is we look through all the available files in our data source, which just happens to be 1. If you loaded a hard drive, it would go through them all. There may be a way to refine this. It's an enhancement, but what it'll do is it goes to the files, sees if it can read that file, and if it can, it says, hey, is this a SQLite file? So SQL databases, or SQLite databases, have pages like we already said, but at the very beginning of the database there's a SQLite header, and that SQLite header, the first 16 bytes has a signature, right, a file signature, and that file signature is just SQLite and the version number. So all this does in this raw file, let's see, we can go to source, is just say, okay, hey, let's go ahead and grab that range, that 16 byte range, and see if it's our file signature. So does it contain SQLite? And if it does, it's a SQLite file, right? So they call those magic strings, as we discussed in class. So once we determine it's a SQLite file, we go ahead and we do the raw parsing. So that's what's done here, right? We load it into this raw SQL file class I've created, and then we do the create pages. So let's go there, source. Alright, so create pages comes in, and in that file header, the file header, so not the page headers, but the file header for the SQLite database, it gets the page size offset. So that's the number of the size of the pages in the database, right? So once you have the size of the pages, right, including the first one, you can divide the file length by the number or the page size, and that gives you all the pages, right? So then we can just start looping through these pages, right, in this iterative fashion, and then we can read in the pages. And so what I did was I created a SQL page class to further abstract this out. So you get a page, you read in the binary, and then you store it in the SQL page class. So we'll go there. And this SQL page has some of the familiar faces we've already seen. B-tree offset, number of cells, cell offset, some values that originally were used, but I'm going to go ahead and clean these up later. And so we just go ahead and grab those numbers. So the free block, the number of cells, and the cell offset, and we use those as said before, right? We just start parsing through the data. We chain down the free block chain, and we go into the unallocated area and we grab that data. We go through some nice clean string functionality, and then we pump it out, right? So you got free, you got unallocated. So that's pretty cool. And so there we go. We've got our raw data parsed. Then we're going to do a full parse. Now for the full parse, they use the Xerial library, right? There's no reason for me to recreate a SQLite library. There's a lot of really good ones out there. So we did that. And so what I'll do is I take this file, and Xerial likes to connect to the files on your hard drive. So we create a temporary file. So if we go down here to this full parse method, it calls the get tables, which is a method we've created in the full SQL parse class, and I'll show you that in just a second, and it creates it. So let's go to the full SQL parse class. It's still got some breakpoints in here, earlier testing. Alright, so we come in here and we say get tables, right? Get tables takes this file, it creates a DB file, and all this is doing is taking the binary from autopsy and writing it to a temporary location on this hard drive so that Xerial can hook to it. And looking through the autopsy sample files and files on GitHub, I found that this is pretty standard, and so that's what we do. And then once we've got it at a temporary file, we have this nice magic string for our temporary file, and we go grab it. And we say, okay, grab it, and then we're going to run our get tables query, right? And that just says select all the names from the SQLite master where type equals table. So it gets all our table names. So we use this to create all our tabs, right? And then we do it here for our string and tab names, create tab. And create tab is a bunch of Java swing, which was pretty new to me, but I feel pretty confident. There was a lot of help from Stack Overflow on this. Tried to include that in my write-up. Credit where credit due, right? But you know, if I missed anybody, thanks Stack Overflow, you're great. Once we create our tab, we then do a query on the table itself, and this allows us to to create those grids like we saw before, right? So get SQL and data, we just go to the full SQL parse and kind of do the same thing. So that gives us our two contents, right? So that's pretty neat. And then for our SQL report, you have to create a panel. And so there's our panel. We've seen that before. And we have our source. And so there's not much to this guy, really. It just grabs data and then reports it back. But our report module, we used a general report module here. Our general report module gets called by autopsy. So if we flagged it, there's in a layer XML file we say, hey, we've added a report. I'll show you. So we say, hey, we've created this report. It can be found here, and this is how you call it. So autopsy knows that it's got a new report, and it knows where to find it, and so it adds it to the list, and it adds that GUI I just showed you to the wizard, which is really nice. So we go back to our SQL report, and this is kind of more of the same. You know, it basically, we're going to create our report file that we looked at earlier. We're going to get our current case. We're going to look through the file, so we go to our content ID, so that's our data source. That was 1 earlier. And then we're going to find the file name that we said in our list of files. And then once we do that, we're going to, we just check to make sure it's a SQLite file. We want to make sure the user is not just mistyping something. The user being us in this case. And then we do a full parse on it, right? We pull in all the data, and then we parse the output. So in parsing the output, we really just kind of loop through it, right? It's a nice array list of strings, and we just comma separate everything, and then new lines where needed. And that creates our report. So there's a lot of room for enhancement in this reporting module, but I wanted to get it in there and get it functional, and hopefully I'll have some time in the future to expand on this. So, and that's pretty much it. I have a few other classes in here, like this J horizontal table, borrowed, not stolen, from Stack Overflow by that author, and that allowed us to do some nice formatting on the grid tables for the final, this grid here, right? So these nice horizontal scrolls and everything. Let's see, is there anything else? And then this fill table, I borrowed this from an author on WordPress, and this converts a data serial result set, so the query result sets to the nice tables that we saw earlier. So yeah, that's pretty much it. As far as building this, it's fairly straightforward. Once you've got it set up as a NetBeans module, there's a lot of documentation on the Autopsy website on how to do that. You just say create NetBeans module. So once you've created the module down here, we'll go ahead and close the existing version of Autopsy. So we close it, and it'll keep building, and we'll open another version here. We were running in debug earlier. It's cheating. So this may take a second. I'm going to pause real quick. Okay, we're back. So to create or load in our module, we go to Tools, we go to Plugins, we wait for it to load. And normally what you would do, this is already here from testing earlier, you just go add plugins, you'll browse out to where it is. In our case, it's in our build folder. We grab it, we say open, and yeah, you want to reload it, and then you'll say install, and it'll start installing. There's no license. Feel free to use it. My disclaimer, don't use it for profit, I guess. So there we go, without giving me credit anyway. And then it's not digital signed. I didn't do that either. So when you load it in, and then it says it's loaded. Alright, so there you go. And so if you go into your install, you'll see that it's loaded and that it's active. So if it ever bugs out, right, this flag will go gray and you have to uninstall and everything. But that's pretty much it. And then from there, it's in your program. So you'll see it like we saw it earlier. It just works. It shows up as it should. So that is pretty much it. Again, this is Hodge Gamble for Digital Forensics 6963, demoing SQLGrab. I hope you enjoyed it. If you have any questions, just let me know. Alright, thanks. Have a good day.